Hi there, welcome to Geometry, section 4, 5 1/2. Kind of a weird little section. It's a half because it's in between 4, 5, and 4, 6, and it actually has to do with right triangles. So we have things that we've been using, right? Side, 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 angle, side, angle, side, to show that triangles are congruent without having to write out all of the corresponding parts. But we also have some right triangle tips. So if you look at each one of these and I said, what would be the reason that we could say that these pairs of right triangles are congruent? In letter A, I'm hoping that you see the single dash, the included right angle, and then the double dash. So that would be side, angle, side. In letter B, I'm hoping you notice the pairs of right angles, the pairs of acute angles, and then that double dash side, also known as the hypotenuse. So that one looks like angle, angle, side to me. And in letter C, hopefully you notice we've got the pairs of right angles, the included sides in the middle, and then the acute angles up at the top. So that looks like angle, side, angle. Well, these are all right triangles. So we actually have some special rules that apply to right triangles. So let's make these speedy. So the first one, by the way, this is in page 215 on your textbook. The first one is leg, leg. Notice, what does it look like? It looks like, if I look at this diagram, right, looks like side angle side to me. The pair of single dashed sides, the right angle in the middle, that would be the included angle, and then the double dashed sides. So basically that says, I'm going to put up here, in right triangles, dot, 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 we can say these things. So I would say, in right triangles, both pairs of legs are congruent. Hence the name leg, leg. There's no hypotenuse congruent here. It's the two pairs of legs that are congruent with that right angle. Hypotenuse angle, if I look at, notice, again, we are lazy, so we abbreviate leg, leg as LL. Hypotenuse angle we call HA. So if I look at the diagram in the middle, what does hypotenuse angle look like? The pairs of right angles, the pairs of acute angles, and then that hypotenuse side. So that looks like angle, angle, side. If I've got a right angle, or sorry, a right triangle, if one pair of acute angles and one pair of hypotenuses, or the hypotenuses, are congruent, then the triangles are congruent without having to name everything else. So I'm going to say hypotenuse and one pair of acute angles are congruent. If that's true, then we can say those triangles are congruent because of hypotenuse angle. If you told me they were congruent because of angle, angle, side, I would also say you were right. It's just a shortcut using the right triangle as one of the angles. Leg angle. So again, LA, if you prefer. Notice when I look at the diagram, I don't know if you see it, but I've got a pair of right angles, the bottom base, whatever you want to call that, legs or sides on the bottom with a single dash, and then the pair of acute angles. To me, this looks like angle, side, angle. However, if I want to use the shortcut for right triangles, I could say, well, as long as one leg and one pair of legs and acute angles are congruent. One pair of legs and one pair of acute angles are congruent. Be careful, it matters where that one pair of legs is. Remember, it's got to be in between the right angle and the acute angle, unlike the HA right above it, where the leg is off to the side. So just watch. That one happens to be a hypotenuse. That might be an easier way to tell apart angle, angle, side, and angle, side, angle, because you know a leg and a hypotenuse. And last but not least, hypotenuse leg, HL. This is the new one. This is an addition to what we have. So let me just jot down. I'm going to say this is a new theorem, postulate, whatever. I'll call it a theorem. This is the new one. So this one could pop up. This looks like angle side side, right? We don't do angle side side for a multiple of reasons. So I can't say that this looks like anything because we've never learned that. It's not a thing. Don't even try to put it on your paper. In hypotenuse leg, we know in a right triangle, as long as the hypotenuse and one pair of legs are congruent. Hypotenuse and one pair of legs. Are congruent. So just like the last section, I'm going to ask you something like, what reason could you use to say that these two triangles are congruent? Try to shoot for the right triangle ones if you've got right triangles. If you don't, then go for the old ones, the angle, angle, side, and all those other ones from 4-4 and 4-5. So let's do a couple quick examples here. Determine whether each pair of triangles is congruent. If yes, state the postulate or theorem that applies. Please notice that I've got on both A and B right triangles. Don't forget in B that reflexive property, anything equals itself. So in other words, that slanted hypotenuse from the top triangle is the same as the slanted hypotenuse from the bottom triangle. It seems silly, it seems weird to even say, but if we do that in letter B, we've now got ourselves a hypotenuse and we've got ourselves a pair of legs, right? So that means I could say that hypotenuse leg is my reason for letter B. If I tried to go a different route, that looks like the angle that is the right angle, side, side. That is not a thing. So I have to go with HL. That is the rule. Letter A, I don't know why I skipped over that, but let's talk about that. Because when I look at letter A, I see I've got right triangles. I see the double arced angles. I see the single arced angles. Do I have any sides? There are no sides marked congruent anywhere. Think back over all of the things that we've done. I think there's 8 of them altogether. Do any of them have any idea that doesn't have at least one side on it? Angle, side, angle, hypotenuse, angle. You have to have at least one side. So for this one, I'm going to say this is no, because angle, 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 well, that's what we've got, is not a thing. That's actually going to pop up later this year when we talk about similar figures. But it is not a thing for congruent. Congruent triangles. So that's a big old no. Those triangles are not congruent, or we can't for sure know that. Remember, you can't make an assumption. So in letter C and D, I've got right triangles here. So I know that I've got my right angles. Check that off the list. I don't have to worry about that anymore. I've got this pair of single dashed sides. Those happen to be legs, right? Not the hypotenuses. And then I've got this pair of single arced angles. So that means I can say those triangles are congruent because of leg angle. If you couldn't remember, you might have said angle, side, angle, and that would work as well. Let's skip over to some weird ones. Let's do F. I think we should be good with F. Because notice I give you a little bit of direction on the side. I've got nothing marked on this diagram. So it says that JM is congruent to KL. You've got to read the directions. So I'm going to single dash those. it says that ML is parallel to JK. I'll put the little parallel signs on there. We've got a lot of things we can do. We can go back to chapter 3. First of all, if those lines are parallel and I've got that right angle at angle K, I have to, because of alternate interiors, or the perpendicular transversal theorem, say that I've got a right angle at M. We could go the reflexive route here. Isn't the side MK on the left triangle the same as side MK on the right triangle? So I could do that. If I did that, marked that with a double dash, that would give me hypotenuse leg, right? I've got the hypotenuses with the single dash. If I didn't do that, reflexive property, I could be real sneaky about this, and this is why I wanted to make sure I mentioned it. I could be super sneaky and I could say, well, I could have some alternate interior angles here. I could say, because technically JM would have to be parallel to KL as well, I could end up saying that these two angles are congruent. And then I could go ahead, because I've got right triangles, I end up with a second pair of parallel lines. And then that would give me a hypotenuse, definitely a hypotenuse, and then one of the acute angles, and that would give me HA. So I could say it's HA, I could say it's HL, the one that we first said. Or if I really wanted to get technical, I could say it was angle, angle, side. Or I could say it was, I guess that's it. I couldn't say angle, side, side. That wouldn't work. So be watching. I mean, there's usually more than one way to see things, especially in something that gives us kind of vaguer directions like F. So that is it for 4, 5 and a half. I'm going to ask you, how do you know these triangles are congruent? You can use the right triangle ones. If you see you've got right triangles, you can always go back to the other ones with the angle, and side, 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 those 4. So there are now 8 options. HL is the only right triangle one that you cannot use in old 1-4. You have to have that one specifically. So be watching for that. And thanks for sticking in there. I'll see you next time.